this is the review assignment 8.6. So let's just go over what we learned in Unit 8, and then we're going to answer the questions. So in Unit 8, it kind of tied together what we did in Unit 7, which is on exponentials and logarithms. So here are integration rules and differential rules on exponentials, on logarithms that you need to know. And you know this by practicing it, not just memorizing this page, and the general power rule. So what did we start with in this unit was diffie-qs. How can you solve a differential equation and the steps that you did that. Then we talked about exponential growth or decay and the connection to diffie-qs. Here's a big one, slope fields. That was the awkward one, right? Where you have to do many little slope lines on a graph, and then you connect the slopes together to make the function. I find it super interesting. It's something I didn't learn in high school when I did it. So this is a new topic in calculus, and I like it. Something different. And then we ended with right triangle trigonometry. And we're going to do more trigonometry. The next in our last unit is all trigonometry and calculus. So I'm super excited about that. And I'm not scared of the work, but I want to do the work. I want to figure it out. And I hope that's your attitude too. So let's start the review together. In number 1, it says, find the particular solution for that. So let's write it down. I'm going to share my screen, my document camera in a second. So I'm going to write down 4y prime equals 3x squared plus 2x. And then it's a particular solution because you're given a point. So y at 2 equals 5. So let's try it together. As always, you could copy the video and what I do, or you can learn it. And that's a choice you just make all the time. What are you going to do? So I want you to learn it. But if you just copy what I'm doing, I can't stop that. I want those that need support to get it. And that means some people will copy and some people are going to learn. So this is a diffie-q. The step number 1 is, can you do step 1? And again, press pause at each step and see if you can work it through with me. So change y prime to dy by dx. You know, press pause and try the next step. So we're going to multiply everything by dx. So we've now, by multiplying everything by dx, the variables are actually already separated. So I don't need to do an extra step to separate the variables, so we've done it. Now we're going to integrate both sides. So the integration of 4 is just 4y. Of 3x squared, you add 1 to the exponent and divide. You add 1 to the exponent and divide. And if I simplify this, you would get x cubed plus x squared plus c. We're given a point, so I'm going to plug it in now. So the point you're given, the y coordinate is 5, and the x coordinate is 2. And I want you to solve for the constant. So 28, 4c, can you solve it for me? So this is 20, take away 12. I can do that. Oops, no I can't. So 20 take away 12 is 8. So if I put it together, I have 4y is equal to x cubed plus x squared plus 8. And then the last step is to divide by 4. Don't make it complicated. Just divide by 4, and you have it. That's the particular solution that we're looking for. All right, try number 2. So press pause, write down number 2, think about it first, and then press play when you need support, not just because you're just copying to get your work done. Number 2, we have dy by dx equals x divided by y, and again, you're given a point. And can we do it? So again, I'm going to go through all the steps. You need to know that you can press pause at any time as we're doing it, so you can do it independently. So I'm going to multiply by dx. I'm going to multiply by y. Now it's separated, so I'm going to integrate both sides. Yep, I try to pause. Maybe you can press pause. Try it. Add 1 to the exponent and divide. So there it is, integrated. Add 1 to the exponent and divide. I'm going to multiply everything times 2. I'm not going to redefine the variable because it doesn't make things much easier. But I am going to plug in the point. So the y-coordinate is 3. The x-coordinate is 5. And I'm going to solve it. Now the truth is I don't actually need to solve for c. I could just stop at 2c and then that's far enough. So in other words, we have 9, we have 25 plus 2c. Subtract 25. So 2c is equal to negative 16. And that's good because that's what I want. So if I come back here, it's y squared equals x squared. And 2c is negative 16. So take out 2c and put in negative 16. The last step is to square root. So if you square root this, the answer could be positive or negative, but not both. What's the y-coordinate? Is it positive or negative? So it's the positive answer. So it's the square root of x squared, take away 16, with the positive sign that you don't see in front. All right, next one. Number 3. In number 3, again, a diffie q. Can you solve a diffie q? Once you catch on to a diffie q, it's not too bad, I think. It's calculus, but a lot of algebra in the calculus that once you click, it kind of clicks. Y prime is dy by dx. So I'm going to try to separate the variables. You can multiply by 3x squared. It's kind of a fraction within a fraction. And you can multiply by dx. And you can divide by y minus 1. And do you have the algebra skills to get to that point? And you could do it in your own order, but we need to get to here. Then we integrate both sides. That's a logarithm. The right side, I'm going to add 1 to the exponent and divide, so the 3's will cross out, and then plus c. To solve for y here, again, if I'm going too fast, you press pause and try it. You write it exponentially. And we know to write it as e to the exponent c instead of adding there to separate them. So to remove the bars, it's plus or minus. We're going to, and you can't just replace it, like you got to show what you do. So plus or minus e to the c, we're going to redefine it. And now I'm going to plug in. So the point that was given was 0, 5. So y is 5, x is 0, and then I'm going to solve it. So if I solve that, e to the 0 is 1, so 5 take away 1 is 4. So I have y subtract 1, 4, e to the exponent x cubed. And then the last step to get y by itself is to add 1. Done. Right? It's not too bad, right? The more we practice. All right, number 4, I'm going to show you my book because you got to look at the slope fields and how would you work your way around the slope fields. So here we go. I know these are challenging slope fields, but that doesn't mean we ignore it or get scared. We just work our way through it, right? So in number 4, here's the slope field that you're given, and I want to think through which of these diffie q's could match that. So one thing I notice are the horizontal lines. That means the slope is 0. So no matter what the y-coordinate is, the answer is always 0. So in other words, when x is 0, the answer should always be 0. So if I plug in 0 for x, it better be 0 no matter the y. So that's good, and that's good. If I plug in 0 for x, that will not make the answer 0 no matter the y, so this is done. If I plug in 0 divided by, it's 0, and then 0 here. So I got rid of 1. by doing that. All right, let's look at another one to look at. Where else do we have horizontal tangents? So let's plug in another number. So let's plug in -1 and +1. So if I plug in -1 and +1, that's this slope right here, the answer better be 0. And if it's not, I cross it out. So does -1 and +1 give you the answer 0? So -1 subtract +1, that's not going to be 0. How about here? -1 plus 1 is 0 times x, so that's okay. Here, -1 plus 1 would be 0, but it's in the denominator. Therefore, that would be a vertical line. It would be undefined, the slope. Nope. And then -1 times 1 is -1. So what's the only diffie q that matches, that could be the answer? And then you could try other points to test them out, but that's the one left standing. So the answer to number 4 is B. All right, number 5. Let's see how I would approach number 5. Number 5, you're again given a slope field. But from that slope field, you're given the actual solution to this. So what the actual curve looks like. These are not diffie q's, but the actual equations. And so what's an approach that I would make here? So one of the approaches I would make is, as I try to organize it, is I would draw one of the solutions. So if I look at the solutions, I would draw them to get a sense of what's happening. And what does it look like? So it looks to me like I have a vertical asymptote. There are no slopes at x equals 0. So it looks like we have a vertical asymptote. So it's going to infinity up here, and then it's slowly curving down here. So I'm going to eliminate functions that don't have a vertical asymptote. So if I look here, e to the x, there was better. So e to the x is gone because that has a horizontal. In fact, all exponentials have a horizontal asymptote. So it's helpful to know your functions so you could cross out the exponentials. The second thing I notice is that pink is decreasing. So when I look at it, it's decaying. It's decreasing. So a logarithm, just ln x, does not look like that. It's increasing. And then D and E show a negative either on the inside or a negative on the outside in terms of which ones could match. So let's just take a point in C. So if I look here at E, the derivative might be helpful for what's left over. So what's the derivative of ln negative x? So what I see is negative x, and the derivative of that is -1. So that's just 1 over x is the derivative. Here, negative ln x, the derivative is -1 over x. So one is positive 1 over x, and the other is -1 over x. So how does that help me? If I put in a positive x coordinate, the slope should be positive. And if I put in a positive x coordinate, the slope should be negative. Well, look here. So the positive x side, the ones on the right, are these slopes negative or are these slopes positive? And so if I plug in a positive number for x, I would get a negative answer or I would get a positive answer. This is not right. So you can tell when you plug in a number for x, a positive number, the slopes are all negative. They're all pointing down. They're decreasing. So the only one that could match that is negative ln absolute value of x. And again, for those that like puzzles, thinking, crossing out bad answers, and working your way through a puzzle, you enjoy it. Those that don't, don't. Number 6. I'm going to go back here. So, where was I at? Oh, I already finished that piece of paper. So, for number 4, you can say the answer was B. And for number 5, the answer is D. And hopefully you followed along in terms of what I did. Number 6. In number 6, you're given a diffie-q. Dy by dx equals x plus y. And then it says find the slopes at these points. So all you have to do is plug in. So if I plug in 0, 0, that means 0 for x and 0 for y. There you go. That's A. And for B, dy by dx, plug in the point 1, 1 into that formula. You get the answer 2. Plug in the point 2, 1. You get the answer 3. You get the idea. Plug in the point negative 1, 0. You get the answer negative 1. And then one more time, plug in the point dy by dx. Plug in the point negative 1, negative 2, and you get the answer negative 3. So you have a formula, and you plug in the x and the y coordinate, and you add them together, and there's your answers. So that would be the slopes at each point. And then for number 7, it says, sketch a slope field. That's 2 by 2 for it. So what does that mean? 2 means 2 in all directions. So that means that for a slope field, 2 to the right, 2 down, 2 up, 2 to the left, and then that, and I'm going to put dots at where we need slopes, and I'll do them in pink. All right, so there it is. That's a 2 by 2. So we already got some. So at 0, 0, the slope is 0. So I'm just going to take these right here, right? So at 1, 1, the slope is 2. At 2, 1, the slope is 3, which is steeper. At negative 1, 0, it was negative 1. And at negative 1, negative 2, it was negative 3. Now, for each one, I just have to add them up to know what the slope is. So it actually isn't too bad. So at 0, 1, add 0 and 1, and the answer is 1. And then at 0, 2, add it up, and it's 2, which is steeper. 0, negative 1, it would be negative 1. And 0, negative 2, it would just be steeper negative and negative 2. So we're just going to add them up. 1, 0, that's 1. 2, 0, that's 2. Just fill in the first quadrant. 1, 2, that's 3. 2, 2, that's 4. Even steeper. The second quadrant, negative 1 and 1, that's 0. Like negative 2 and positive 2, that's 0. Do you see a pattern? So 1, negative 1. As soon as I see a pattern, I fill it in. 2, negative 2, they add up to 0. So the slope of 0 is horizontal. All right, how many points do I have left? Here, up here. That's negative 1 and 2, so that's positive 1. I also see a pattern here. See positive 1 all the way down, so this is positive 1. Any other patterns to see here? So this is negative 2 and 1, which is negative 1. That's a pattern. So here at 1, negative 2 here, do you see diagonally that's a pattern? Now we got a few left here. So this is negative 2, 0. This is negative 1 and negative 1. So that's a pattern. That's negative 2, making a diagonal. Negative 2, negative 1, and then negative 4, negative 2, negative 2, which is there. So there's your slope field. That's 2 by 2. And then it says, for the differential equation from 6, sketch a particular solution. So I'm going to do that in yellow, I think, if it sticks out enough. All right, through 1, negative 1. So go to 1 and negative 1. There it is. And what's that solution? So what's happening at 1 and negative 1 is it's a horizontal slope. So what does that mean? So that means at 1 and negative 1, it's a turning point. So that's either a low or a high point. So if you look at it, look beside to the right and to the left, it's a low point because it's rising. So from here, it rises to the right, and then to the left, it also rises, following this. Whoop. So there's your particular solution. Maybe I'll do it in pencil. So that point is a low point, and then you follow the curve from there. So the slopes to the left, the slopes to the right, and you have your curve. Is it going to tell you to solve it in number 7? No, we did number 7. And we did, that's number 8 too. Number 9 is completely a different question. So there's 7 and there's 8. All right, turn the page for number 9. So we just did 6, 7, and 8. So number 9, I want you to read it. So press pause and read it. Then press play. All right, so we're going to start with y equals CE to the KT, the initial production. So the rate of coal production from a coal mine was 2 million tons per year. That's the initial amount, 2 million. So that's going to be what C is, 2 million. At the beginning of, and that's in 1990. In 1996, that rate went down. So how many years is it from 90 to 96? So obviously that's 6 years. And now what's the production? And it's 1.2 million. So I first need to find the decay rate of that production. So I'm going to use a calculator. So there's my setup. And I need to find what K is, and then I'm going to save it in my calculator. So let's do that together. So take out your calculator. So I'm going to press menu and then algebra, and then I'm going to solve it. And it's 1,200,000 equals 2 million E to the 6K, or K6. And then I want you to solve for K. So go comma K. And then once you have that, you're going to highlight it and copy it. So come back here with your cursor pad, click on it at the beginning, and then try the best you can to highlight. Sometimes it's a little finicky. So click and highlight on it, and then go Control C. So now it's in there. I'm going to go negative 0.085 here. Then I have the equation. Oh, and I know what C is. Sorry. So it's 2 million. All right, so that's what we have. And then the question says, find the particular equation for the amount of coal mined per year. That's what this is. So this is part A. We found the particular equation that goes with that story. Part B. What's the half-life of this production? So half-life is when I divide. So how long would it take to become half of that production? So that's half. So if I divide by 2 million, the answer would be a half. So this is what I'm left with. And then again, I'm going to use the calculator to find the half-life. Now when I use my calculator, I'm going to paste in to find it. So again, I'm going to go menu and algebra and solve. And it's half. Oops, that's my mistake here. Try it again. Menu, algebra, and solve. And I'm going to paste Control V and then T to find what that time is, comma T. So I got about 8 years, or 8.141 years. So that's the half-life. In 8 years, every 8 years it'll become half its size in terms of production. C, the year when it will no longer be profitable. So in the question, it'll be profitable until there's 200,000 tons of coal produced. So 200,000. So there's the equation. So it'll be profitable how many years, and then we'll put the actual year in there. So solve that equation. I'm going to do it too. So go menu and algebra and solve. 200,000. 2 million. Make sure you have your zeros. Make sure you paste in the rate. And then we're going to solve for t. So this is what it looks like. So in about 27 years. So the year we started was 1990. So 1990 plus 27 years, what year would that be? And so what would that be? 2017? So in the year 2017, you'll no longer be profitable. All right, there's number 9. Number 10. In number 10, it says, write a sentence saying from problem 9, if you had a rate of coal production what would number 10 represent? What would it represent? So this is the rate of coal production. So what would it represent? It would be the years from year 0 to year 6, or the 6 years. So the integration of that rate would be the actual amount of coal production, not the rate. So if you're given a rate and you're integrating that rate, then the limits tell me the years. So from 1990 to 1996, the integration of this represents the total amount of coal produced in those years compared to our rate. Number 11, approximate the value of the integral from number 9 using the table at the right. And then where R values are to the nearest thousands of tons per year. And it says do a midpoint Riemann sum. So let's make sure we're looking at the same thing. So here's our table to the right. This is in thousands. So that's not 2,000, but 2 million. That's the initial production, and then it goes all the way down from there. So you should add 3 zeros to everything you see when it says 1,000 tons per year to the nearest that. Okay. So what would a midpoint Riemann sum, what does that mean even? So that means we're going to integrate this using rectangles. And so how many rectangles do we have? We have 3 of them. So we're going to integrate from 0 to 6, that rate. And the first thing I need to know is the width if we're using 3 rectangles. So let me show you how I would do that. So the common width, you take the upper limit, subtract the lower limit, and divide by how many rectangles you have. So each rectangle is going to be a width of 2. Sometimes it's helpful to visualize it. So if I go from 0 to 6, right, and every 2, so the first rectangle goes 0 to 2, 2 to 4, 4 to 6. And midpoint, what's the value that we're going to find for midpoint? So the middle between 0 and 2, we're going to use 1 and then 3 and then 5. That's what's going to give me my middle values. So go back to the chart. So for 1, I'm going to put in 1,837. For 3, I'm going to put in 1,549. For 5, 1,307. And then I'm just going to use my calculator, not very fancy. So put that in your calculator, and the answer you would get is 9,386. And that's this, right? Tons of coal. So at that rate, that's how much coal would be produced using a midpoint Riemann sum for those 6 years. And then it says use a trapezoidal rule. And again with 3. So for a trapezoidal rule, we're still integrating from 0 to 6, that rate. The number of trapezoids is 3. So the width of each would be the same. So we have 3 trapezoids. To find the width of each trapezoid would be the same, so it's 2. Now for a trapezoidal rule, it starts with 1/2. So the formula for a trapezoid is 1/2 times the common width, which we said is 2. And now we're not going to use the mid values, we're going to use each one. So it's 0, and then 2, and then 4, and then 6. And these middle ones we have to double. So at 0, it was 2,000. In 2, we double it, and it's 1,687. And then again, we double it. For 3, it's 1,549. No, sorry, not 3, sorry. Double it 2. Double it 4, which is 1,423. And then the last one we're going to plug in is 6, which is 1,200. So that's what it looks like. And then you just put all of that in your calculator, and you should get the answer 9420. And then add 3 zeros to it. So there's the estimate of the amount of coal produced in those 6 years using the trapezoidal rule. This is the midpoint rule. So you can see the answer is just a little bit different. And then in question number 12, use your calculator to find the actual value of it. So if I use my calculator to find the actual value, I go menu, actions, menu calculus, then integrate. And again, I'm integrating from 0 to 6. And the equation I put in is the one I found in question number 9. So in question number 9, it was 2,000,000, 1, 2, 3, 1, 2, 3, e to the exponent. Remember, we go Control V. It's already in there, right? That's the rate. T. And then we're integrating with respect to t. So that's the one we came with, the number 9. So what's the actual amount there? And so it's 9 million. And it says to the nearest 1,000. Let me write this down. So what did we put in our calculator? We integrated from 0 to 6 what we came up with. So we came up with this in question number 9. And the answer would be 9,396,000. And if it's to the nearest 1,000, it'd be actually rounded up. So it'd round up to 7. So it'd be 9,397,000. And that's how many tons of coals there'd be. Which one was more accurate? The trapezoidal rule or the midpoint Riemann sum? So can you see the midpoint? It was actually a little bit more accurate. All right, there's number 12. Now we're going to do some trigonometry without using our calculator. So let's see if we can do some basic trig here. So what's the value of sine at pi? Pi on our unit circle is on the left. The point on that unit circle is -1, 0. Sine goes with the y coordinate. So that answer is -1. Number 14, cosine, 3 pi over 2. 3 pi over 2 is at the bottom of our unit circle. That point on there is 0, -1. Cosine goes with the x coordinate. So that answer is 0. Number 15, tangent, 4 pi over 3. So 4 pi over 3, because it's over 3, it's a 60-degree reference angle. A 60-degree reference angle, the order of the points is 1/2 and √3 over 2. Tangent, by definition, is y over x. So if I take the y coordinate over the x coordinate, I get √3. And then the last thing I need to think about is what quadrant it's in. So 4 pi over 3, 1 pi over 3, 2 pi over 3, skip 3 over 3, and 4 over 3 is in quadrant number 3. So that means both the x and the y are both negative. So a negative divided by a negative, and you have your answer, positive √3. Number 16, secant, 5 pi over 4. What's the value there? So again, over 4 means it's a 45-degree reference angle. The order of the points is √2 over 2 and √2 over 2. Secant is the reciprocal of cosine. So if I take the x coordinate, do the reciprocal of that, I get 2 over √2. You don't have to make it look any prettier than that. So it is 2 over √2. What quadrant are we in for 5 pi over 4? So we have 1 pi over 4, 2 pi over 4, which we're going to skip, right? 3 pi over 4, 4 over 4, and then 5 over 4 and 7 over 4. So what quadrant are we in for 5 pi over 4? And in that quadrant, the x coordinate is negative. So this is -2 over √2. Number 17, cosecant, 7 pi over 6. So how do I find the value of that without a calculator? The denominator is 6. It's a 30-degree reference angle, and the order there is √3 over 2 and 1/2. Cosecant is the reciprocal of sine or the reciprocal of the y value. So the reciprocal of 1/2 is 2, and then the last thing I figure out is the quadrant that it's in. So we have 1 pi over 6, we have 5 pi over 6, 7 pi over 6 is in quadrant number 3, and the y coordinate is negative there. So this answer is -2. All right, one more like that, number 18. In number 18, we have cotangent, and it's -3 pi over 2. So when an angle is negative, you measure it clockwise. So if you go -3 pi over 2, it actually end up on top of the unit circle. So the top point is at 0 and 1. Cotangent is the reciprocal of tangent. So the definition of cotangent is x divided by y. So if I go the x divided by the y, 0 divided by 1, the answer is 0. If 0 was in the denominator, then it would be undefined. I know it's not easy. It's like the first time you learned your times tables. It's not going to be easy. You're going to have to work at knowing how to figure out your unit circle. All right, number 19. We also had a lesson on L'Hopital's rule, which had to do with limits. So let's do some of those L'Hopital rule questions here. So L'Hopital's rule is when something is indeterminate. So step 1 is to plug in pi over 2 and determine, is it indeterminate? So when I plug pi over 2 in for theta, it is not indeterminate. We have a pi over 2 in the denominator. And for the AP exam, believe it or not, you don't have to simplify your final answer. So in other words, I can leave that as an answer and it's good and you get full credit. So only simplify and use the unit circle when you have to go further in the question. At this point, there's nothing further. It's the end and you could just write it that way. Number 20. The limit as x approaches 2, 3e to the x subtract 2, 4x subtract 8. So we're going to solve this. Again, if I substitute, think of it as the numerator and denominator. So let's separate it so you can see it. So plug 2 in here and you get the answer 3. If I plug 2 into the denominator, you get the answer 0. This is not indeterminate. This is 3 over 0. Do not write down 3 over 0. So we separate it so you don't write down something mathematically that is incorrect, but we can say that this limit doesn't exist because it's 3 divided by 0. It's undefined, so it doesn't exist. Number 21. The limit as x approaches infinity. So that's a right-hand behavior question. And what I look for is power over power. So if I look at this carefully, as it's going to infinity, look at the two power terms, e to the x and x squared. If the numerator is more powerful, if it's increasing faster than the denominator, this answer is infinity or doesn't exist. If the denominator would increase faster, the answer would be 0. And if it's the same rate, you would divide them and see what the number is. So for 21, you could either say it's going to infinity or it doesn't exist. Number 22. Get my paper over there. All right, so for number 22, we have the limit as x approaches infinity again of ln x plus 1 over x plus 2. So again, I'm looking at the numerator and denominator. Do you see that the ln increases slower than a line? So the slope 1 actually increases faster. So if I look at the denominator, that's what it looks like. If I look at the numerator, that's what it looks like, right? So as this over time, the line increases faster than the logarithm. So that means this is going to 0. 23. These are great questions on multiple choice and great that you can do it quickly. So the limit as x approaches infinity of 5x to the 4th subtract 3x squared plus 5, x to the 4th plus 3x subtract 7. So again, another question going to infinity. This is a right-end behavior question. Power over power. They have the same power. So just divide and you get your answer. So the right-end behavior there is 5. So the closer it gets to infinity, the closer the answer is 5. Number 24. In number 24, you're given that tangent theta equals negative 5 over 12, and that sine theta is greater than 0, and to find cosine theta. That's my goal. All right, what do I do? So if sine theta is greater than 0, that means the y-coordinate is above. It's either quadrants 1 or 2 because sine is the y-coordinate. If tangent is negative, it cannot be quadrant number 1. So the only quadrant it could be is in quadrant number 2. In quadrant number 2, tangent is negative and sine is positive. What do we know is that tangent by definition is opposite, which is negative 5, over, oops, I did that wrong, over adjacent, which is 12. So this is negative 5 over 12. Opposite over adjacent. Use the Pythagorean theorem, and you'd find that this answer is 13. And then from this triangle, cosine would be 12 over 13. Done. Number 25. Solve an equation. So we have 3 tangent squared theta subtract 1 equals 0. And it says solve that from the interval from 0 to 2 pi. So to get tangent squared by itself, I would add 1 and divide by 3. When I square root, the answer could be positive or negative, the square root of this. So the square root of 1/3 is 1 over root 3. And if I'm just going to leave it that way. This is y over x. So when I think of my reference angles, this is what I'm thinking of. 30 degrees, root 3 over 2 and 1/2. 45 is root 2 over 2, root 2 over 2. 60 is 1/2 and root 3 over 2. So that's what I'm thinking of. Which one of these, when you go y divided by x, gives you 1 over root 3? So you can see it's this one. 1 over root 3, y over x. And because it's positive and negative, it's all of them. So 30-degree reference angle would mean it's over 6. And so in quadrant 1, in quadrant 2, in quadrant 3, and in quadrant 4, and you have everywhere where tangent theta is equal to 1 over root 3, positive or negative. And there's your answer. Number 26. And soon the sun is going to get me straight in the face, and I'm going to stop, move my desk, probably a second video. 26, we'll see. So in number 26, you have 3 cosecant squared theta minus 4 equals 0. I think I'm going to get done to 28 and then stop and then do a second video and move my desk. That's what I think I'm going to do. Solve this equation. So cosecant squared, add 4, divide by 3, take the square root. So it's positive or negative. The square root of 4 is 2 over root 3. So we're looking for which of the reference angles, when you do the reciprocal of the y-coordinate, gives me that answer. And the answer is this, that the 60-degree reference angle, when you do the reciprocal, gives you that. So the reciprocal of root 3 over 2 is 2 over root 3. And that's what I'm looking for. And it's positive and negative. So that means it's all the quadrants. So what's a 60-degree reference angle? So it's 1 pi over 3, 2 pi over 3, 3 pi over 3. That simplifies. So the next one would be 4, and the last one would be 5. And that's knowing the unit circle by memory. All right, number 27. In number 27, you have the derivative, you have an integration, and you have some trigonometry. All right, this question is a fundamental theorem of calculus question. Part 2, the sequel. This is just a substitution question, not a trigonometry question. So what do you substitute in first? And then after you substitute in, what's the derivative of 3x? It needs a hook, and then subtract. And then what do you plug in for the bottom limit? Just substitute in. Take the derivative of 2x, and there's the hook, and you have it. So that's a fundamental theorem of calculus question rather than just a trigonometry question. And this is our last one for this video, 28, and then there'll be part 2 after this. Find the average value of that from 0 to 2. So the average value is an integration question. So I'm going to integrate from 0 to 2 x times e to the x squared, and then in the denominator I subtract the limits. So 2 take away 0. So that's an average value setup. Without a calculator, how would I keep going? So 2 take away 0 is 2. This is actually 1/2 in front. So it's 1 over 2. Then I need to set this up to be calculus friendly, to be able to integrate it, to do the anti-chain rule. The derivative of x squared is 2x. So that's what I need. What it was before and what it became. So it was 1, and now it's 2. So I need another 1/2 in front. So if I do that together, I get 1/4. And then I can unhook 2x. And then the rule for e is copy it. And then I'm integrating from 0 to 2. So that's my substitution. And then the last step is to plug in. I don't need to simplify it. So plug in 2. Subtract. If you plug in 0, you get 1. So that is your answer. That is the average value. 1/4 e to the 4 take away quarter. All right, Mr. G Math over and out. I'm proud of you. We're more than halfway done. Until next time, that'll be part 2 of the video. See you then.